Hello students and welcome to this lecture series by AKtU. I am Dr. Supriya Frailatpam, Assistant Professor in the Department of Civil Engineering in BBD ITM. I will be taking unit 3rd of Environmental Engineering with code KC 603. This is the final and the last lecture, the 8th and the last lecture for unit 3. In the last classes, I have already talked about BOD and all the physical and the chemical characteristics of water and wastewater. Today, I will be introducing a new topic called population equivalent. So, actually it is a very important topic, and what is it? Population equivalent refers to the amount of oxygen demanding substance measured in BOD or BOD 5 in wastewater whose oxygen consumption during biodegradation equals the average oxygen demand of wastewater produced by one person during one day. So, what actually does it mean? It means that when say let me explain this with an example. Okay. Say for example, we have an industry here. Okay. So, say for example, I have this a river here and one industry here A, another industry here B. Okay. A is discharging at 1000 liters per day with, and the BOD of this effluent is say for example 1000 milligram per liter BOD. Okay. And B is discharging say 10,000 liters per day, okay, and it is BOD of the effluent is say 100 milligram per liter. So, since A is discharging only 1000 liters, whereas B is discharging 10,000 liters, that is 10 times the amount of effluent. So, how will you charge this both this industry? Say for example, I am a resident of this town and I want to charge both A and B because they are polluting my city, right. So, but how I am going to charge? Should I charge then A lesser because it is only producing 1000 liters, or should I charge B lesser because it is producing effluent with lesser BOD? So, I should be able to do things very fairly and very rationally, right. So, that is so population equivalent is that term which will make me decide if how I am going to charge and how I am going to charge A and how I am going to charge B. So, what will I see? What I will see that how much of pressure A is exerting on my wastewater treatment, the wastewater treatment of my city, and how much of B is exerting on the wastewater treatment of my city, right. So, what will I do? What is the total BOD of this? This will be 1000 into 1000, which will be 10 to the power 6 milligram per liter, right. This is the total BOD for A, and for B how much is it? 10,000 into 100. So, 1, 2, 3, 4, 5, 6, 10 to the power 6 milligram per liter. So, even though A is discharging a smaller amount of effluent than B, but both the exertion of A is giving a similar load as B. So, what will I do? I will have to charge both A and B similarly. So, if I am going to take 10,000 rupees from A, I am also going to take 10,000 rupees from B. So, that is the what the population. So, it is thus used to charge industry causing population causing pollution rationally and fairly. So, what is population equivalent? Population equivalent is standard BOD or BOD 5 of the industry in kg per day and standard BOD or BOD 5 of domestic sewage per person per day. Like अगर इसको बहुत सिंपल टर्म में बोले तो पॉपुलेशन इक्विवेलेंट वो वाला टर्म है जो एक्चुअली एक पर्टिकुलर इंडस्ट्री या कहीं कुछ इंडस्ट्री से वो बता सकते हैं कि हमको एक इंसान के हिसाब से अगर से फॉर एग्जांपल उसने एक एफ्लुएंट प्रोड्यूस किया तो वो एफ्लुएंट कितने लोगों के हिसाब से उन्होंने प्रोड्यूस किया। जैसे अगर इंसान जनरली क्या होता है 0.8 kg पर डे पर पर्सन इतना BOD एक्सर्ट करता है एक पर्सन। सो अगर वो इंडस्ट्री जो है वो कितने लोगों का पोल्यूशन प्रोड्यूस कर रहा है उसके हिसाब से विल चार्ज दैट इंडस्ट्री। ओके, नाउ लेट अस कम टू COD. COD is actually very important obviously, right? So what we have already talked about BOD में हमने ये बात किया था कि both biologically and both biodegradable organic matter. In COD we are going to include both biodegradable oxygen organic matter and non biodegradable organic matter, and oxidation is going to take place by a very strong oxidizing agent, right, like potassium chromate, right. So, BOD test takes minimum 5 days time, and due to this it is not very useful in control of treatment processes. An alternative test is COD. It is widely used as a means of measuring the amount of organic matter in waste. What is COD? The equivalent amount of oxygen required to oxidize organic matter present in water sample by means of a strong chemical oxidizing agent like potassium dichromate or potassium permanganate is called chemical oxygen demand. So, in BOD what we are going to do, we are using bacteria, so we are using microorganisms, whereas in chemical oxygen demand or COD what we are doing, we are using a very strong oxidizing chemical. The COD values include oxygen demand created by biodegradable as well as non biodegradable, right. So, it was COD में complete हमको complete picture देंगे. COD will give us the complete picture of how much of organic matter is present in that wastewater. Hence, COD values are always greater than BOD. Maximum what may happen, it may be similar to BOD, but if not it will be always more than BOD. In comparison with BOD 5, COD measurement has an advantage in that it requires a short digestion period of about 3 hours. rather than the incubation of 5 days period required for the BOD 5 measurement. So, BOD में 5 दिन लगता है, COD में hardly we take 3 hours. In COD what happened is that how do we do COD test? A known quantity of wastewater is mixed with a known quantity of standard solution of potassium dichromate and the mixture is heated. The organic matter is oxidized by potassium dichromate in the presence of H2SO4, which is sulfuric acid. The resulting solution of potassium dichromate is titrated and the oxygen used is unoxidizing the wastewater is determined. This is the COD. So, whatever experiment you are doing it chemically, right. Now, let us come to the end of this lecture sort of bacteriological characteristics. We have talked about the physical characteristics and then we have talked about the chemical characteristics. Now, the bacteriological characteristics of the wastewater. Sewage contains many microorganisms like bacteria, algae, fungi, protozoa, etc., with bacteria being the most predominant. So, sewage, when you talked about sewage, when you talk about wastewater, obviously you know it is going to have lots of microorganisms. Most of the bacteria found in the sewage are harmless, non-pathogenic bacteria. They are helpful in oxidation and decomposition of sewage. However, some bacteria are disease producing pathogens which may affect the health of the public. Some may cause illness. In case of sewage samples, the routine bacteriological tests as performed for wastewater samples are generally not performed because of high concentration of bacteria present in it. When we talked about bacterial characteristics of water, so we were conducting MPN tests to check if it is safe for drinking and all, but you are not going to drink wastewater, right, and you already know that microorganisms are going to be there, you are not going to check if it is present or not, right, it is already there. So, we generally do not do any bacteriological, any type of any types of bacteriological tests for sewage, but at a time of certain outbreaks like epidemics, we will do some small some tests to confirm what type of pathogens we are dealing with, right. So, at a time of outbreak of epidemics, certain tests may be done to find the types of pathogens. Now, let us talk a little bit on the disposal of wastewater. There are two general methods of disposing wastewater. So, we have talked about wastewater, what we will do? Well, you get wastewater and then you treat it. Even if you treat it or if you leave it untreated, there are certain ways by which it is disposed. The first one is disposal by in water. So, you actually mix that with a huge body of water, be it a river or a sea or ocean or a lake, right. Another is disposal on land, like you sort of treat a little bit of wastewater and then you use it for irrigation, right. So, disposal in water, that is dilution. Treated waste, a sewage is discharged into a river, stream, lake or sea, and there it is purified by self purification process. Like in natural system, whatever sewage will be done used, the BOD will be present. What will happen? They are going to be oxidized in naturally by the by many physical and bacterial by certain bacteria, by the physical forces, like for example, mixing, dispersion and then dilution, okay. And then next will be disposal on land. So, in disposal in land, we call it effluent irrigation or broad irrigation or sewage farming. The sewage effluent, either treated or diluted, is generally disposed of by applying it on land. So, what you are doing? You are sort of irrigating, right. So, the percolating water may either join the water table or be collected by a system of under drains, right. It may increase crop yield, as sewage contain lots of minerals and other elements which may act as a fertilizer, but only after ensuring the sewage effluent is safe. Sometime if you have, we are talking about toxic sewage, we are not going to use it. If it is if we are sure ki it is going to, like, there is many things which may happen, go wrong with this type of disposal, but people but there is if when there is no other way, we do it. And but most of the time we will before disposing on land, what we will do, we will go for a complete treatment, and then we'll, if we find the effluent safe enough, then we will go for it. Okay. Okay. With this, I have finished the theoretical part of unit 3, but we will be continuing with this problem. This is a very small problem. This was in your question paper for the year maybe 2 or 3 years back. So, it is a very simple question. The sewage, the average sewage flow from a city is 80 to the power 80 into 10 to the power 6 liters per day. The average 5-day BOD is 285 milligram per liter. Compute the total daily 5-day oxygen demand in kg and the population equivalent of sewage. Assume the per capita BOD of sewage per day is 75 grams, right. So, here they have given how much is the sewage, right, the amount of sewage. Here they have given BOD of sewage, right. So, you have to calculate the 5-day oxygen demand in kg and the population equivalent. So, what we have here? So, quantity of sewage flowing per day is 80 into 10 to the power 6, which is already given. Average 5-day BOD is 285 milligram per liter, which is given. Then total, so total daily 5-day oxygen demand will be the BOD into the the quantity. Okay. So, 285 into 80 into 10 to the power 6 milligram per liter, you work out this milligram, which gives to 22800 into 10 to the power 3 grams. And what is going to be the population equivalent? This much of oxygen demand is given. So, what is the population you expect from this? What is the population you expect from this type of oxygen demand? Okay. Population equivalent will be this divided by the per capita BOD of sewage per day, okay, which will be 75 grams. So, here you have to remember that this is in grams and this is also in grams. So, 22800 into 10 to the power 3 divided by 75, which gives a population equivalent of 304,000. Okay. So, this is a very simple question. I think it was for maybe I do not know, maybe 7 marks or something like that, or 2-3 marks. Now, next come to the next question problem. This is actually very important. Calculate 1 day 37° centigrade BOD of sewage sample whose 5 day 20° BOD is 100 milligram per liter. Assume deoxygenation constant at 20° centigrade, that is Kd 20 as 0.1. So, here what you have? You have, they have given that, so what here what you have to determine? You have to here one is, first thing is the temperature from 37° centigrade to 20° centigrade. Another is day, from 1 day to 5 day, right. So, that is what you have to do. So, what is given here? Solution 5, what is given here? 5 day 20° BOD is 100 milligram per liter, right. So, 5 day 20° centigrade BOD is 100 milligram per liter. So, what you have to do? First we want the first you want to find out what is this value, L value, what was the starting organic content, because this is not going to change with time. Okay. This will be remain, this is a constant, but this will be changing with your time, right. So, you have this. So, BOD at 20° centigrade after T days is given by this, we already seen, YT equal to L open bracket 1 minus 10 to the power minus Kd 20 into T. This you already it is already given that Kd 20° equal to 0.1, YT is already given here, this is YT 100. So, substituting you get the value of L here as L equal to 146.2. Okay. So, what do you do here? Then now you already know this. Now, you have to substitute this at this particular temperature. So, you already have this. So, but now but you require this Kd at 37° centigrade. Okay. So, for that we already have the equation, this equation, that is Kd at T degree centigrade equal to Kd at 20° centigrade into 1.047 T minus 20°. Okay. So, here for Kd at 37° centigrade will be Kd at 20° centigrade, that is 0.1 into 1.047 into 37 minus 20, that is you were required for 37, and which works out to be 0.216. Now, let us find YT for 1 day. So, you already know this value and you already know this value. So, it is very easy now for 1 day. Here is that YT at, that is the BOD at 37° centigrade for 1 day, YT equal to this equation, YT1 will be equal to, you substitute the value of L, that is 146.2 into 1 minus 10 to the power 0.218, which is this value into 1. Why? Because you require for 1 day, which works out to be this. So, Y1, that is BOD at 1 day at 37° centigrade will work out to be 57.75 milligram per liter. So, this is the second problem. I hope you understand this. The third problem is here. The following observations were made for a 3% dilution of wastewater. Okay. Dissolved oxygen DO of aerated water used for dilution is 3.0 milligram per liter. Dissolved oxygen DO of diluted sample after 5 days incubation is 0.8 milligram per liter, and dissolved oxygen of original sample is 0.6 milligram per liter. Calculate the BOD of 5 days and ultimate BOD of the sample, assuming the oxygenation coefficient at test temperature as 0.01, that is here Kd equal to 0.1, right. So, what does this 3% dilution means? Let us talk about it first. Okay. So, 3% dilution of wastewater means that 3% is wastewater and the remaining will be the dilution water, means the 3% will be the wastewater, the core thing, the sample, and then the whatever remaining, the 97% is going to be your dilution water, which may be distilled water or whatever they are using, right, aerated water. So, 3% of dilution wastewater means 3% the wastewater or the sample, right, and 97% of dilution water, right. So, DO of the diluted sample. So, what we want for calculating BOD, if you remember, you will have first initial DO minus final DO, right. This will, and then you multiply it with some other things, right. So, for this you require, for finding out this initial DO and your final DO, you want the initial DO of the in the BOD bottle, right. So, DO of the diluted sample, what is the sample? DO of wastewater into its amount and DO of the dilution water into its amount. So, what is the DO of the wastewater? DO of the original sample or the wastewater is 0.6. What is the amount? 3%, right. 3% is 3 by 100 plus the, what is the amount, the DO of the dilution water? Dilution water is 3 into amount is 97%, that is 97 by 100. This works out to be 2.928 milligram per liter. So, this is the DO of the diluted sample. Okay. So, this is the DO of this diluted sample at day 0, that is at the starting, the initial DO. Okay. Now, what is the final DO? DO of the incubated sample after 5 days was given here as 0.8 milligram per liter, that is, this is the final DO, right. Now, DO consumed in oxidizing organic matter will be this minus this, that is this minus this. So, 2.928 minus 0.8, which works out to be 2.128 milligram per liter. So, this is the DO which is consumed, which is used. Okay. Now, what is the BOD now? So, BOD of 5 days will be equal to DO consumed minus into the dilution factor. Okay. So, here the dilution factor. Now, what was the dilution factor, if you remember? It is already there in the BOD slide, if you remember it. So, BOD of 5 days, that is BOD 5 will be equal to DO of the DO consumed that is 2.128 into dilution factor, that is 3%, it was 3% if you remember. So, 3% in the sense 100 divided by 3. Okay. So, it works out to be 70.93 milligram per liter. So, this is the BOD 5. You have already have the BOD 5, now you require the ultimate BOD. The ultimate BOD in the sense that how much if the the BOD which is going to the amount of organic matter actually which is present, right, that will be the ultimate BOD. So, you have the equation here y t equal to L 1 minus 10 to the power minus k d t, right. So, here we already know this part, right, it is for BOD. So, and t is 5 days. So, y 5 equal to L 1 minus 10 to the power k d into 5. So, here we have already got that y 5 equal to 7.93 and k d is already given. So, when you substitute 70.93 equal to L 1 minus 10 to the power minus 0.1 into 3, which works out to be L into this. This L is going the ultimate BOD, that is the organic matter which is present. So, it works out to be L equal to 70.93 divided by 0.684, which works out to be 103.7 milligram per liter. Hence, the ultimate BOD is 103.7 milligram per liter. So, this is the ultimate BOD. So, here what we have seen here. So, you have to remember you have to remember all those equations, very important, and with these problems I finish unit 3. Thanks a lot for listening to me. Thank you.